Okay. Hi, everyone. This is Algebra 3. So this was our Desmos activity that we did in class. So this is the week of October 26. Okay, so I just wanted to sort of like go over this again because it was a little bit much. So we have a problem. And so if we look at it, student council is selling tickets to the winter dance. Okay. Tickets cost $5 per person or $8 per couple. So there's two variables, right? So we're going to have I'm going to like color coordinate. Like the amount of tickets, that's our Y. And then, for X, it's down here. So I have two variables because it's math. And so that changes. This is a system of two inequalities. So maybe I'll write that up here. That's probably a good idea. System of two inequalities. Okay. So the equations that we wrote in class were in the form ax plus by is something like less than, greater than, equal to, c, doesn't matter. So in an equation, we would say this, and this is called standard form. Standard form. Standard form is really great, especially for systems, yeah, and also it's good for like elimination if we had to solve it algebraically. And so what it asks us to do here, it says in rows 5 and 6, which it's fine, write a system of two inequalities. So that's what we're going to do. So it just won't be over there. So let's maybe write it. I'm going to move that. So one, I have something about like money, right? I have a money equation. And then the second one, I have like the number of people. And so let me finish reading. I didn't finish that. Okay. So to cover expenses at least, so that's money, right? So here's my money, is at least $1,200 worth of tickets must be sold. And then for like the number of people, let's make that be green, no more than 500 students can fit into the gym. So that has to do with my people. So I'm going to have a money equation. I'm going to have a count equation. And so right away I hear, maybe I want to like say this. So at least $1,200, right? So it can be more than, yeah, right? Like it could be 1,201. And then for so this in first period I messed up, but it's $500 is our boundary, no more than. So that means that's my upper bound, and I can't actually have 500 be allowed. And so in first period, we accidentally, by we I mean me, we accidentally just called it a strict inequality, but actually it includes it. Okay, so I'm going to put all this together. So I'm going to write it in standard form, and I'm going to use these parts here. So let me get my pen. So I'm going to have $5 tickets. So 5 is the $5 per ticket. And then I'm going to have the couple tickets, right? So if you go with a friend, so plus, so here's my slope, my rate of change is 8, and however many of those I have. And then for my money, I'm going to have that be bigger than or equal to 1,200. Okay, so for the people, it's similar, but here I just have some number X plus some number Y of the couple people. And then that has to be less than or equal to 500. Oofta. Okay, So those are our two equations. And really this is like a review, unfortunately, of like standard form. So I'm going to use standard form. I'm going to use these two facts that I know, and then I'm going to write two equations. Okay, so let's look at the next slide. Okay, well, the colors are different. That's okay. But here, let me try. So I think this was this, right? And this was x. And then we had this be y, y. So here, 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 here. Okay, great. So this is the graph, right? And so when you type it in, so again, in first period, me, messed up in the sense that like, I don't know. So they're both solid lines. So any point here, let me get black maybe. So like this works. So 200, 200 is a solution, right? So it's like in the overlap, let's say. So it works for the purple and it works for the red. Yeah. And so what's allowed to have happen is we can have boundary points, right? So like these are working, like anything in here, this, it's really, I'm going to use a highlighter. Let's get green actually. Any of this stuff is going to work. Anything in here. So this, maybe I'll switch here. This is our solution. Technically it's the whole overlap, but we do kind of want to focus here on just like our first quadrant because we're dealing with people and money. So we don't want to have like a negative money. We don't have negative people, stuff like that. So the solution is the overlap. Solution is overlap. So again, any point within there works. Maybe I actually want to kind of make it brighter. Anything in here works. Yeah? Okay, so that's how something like this works. Let's look at the next slide. Oh, right. Okay. Forgot about this. So here it was create your own. So it gives you the solution. So we have the solution right here, right? So it's right here. And it's asking you to sort of create your own. And so what, let's see how well I can do this. So for example, 5, it's just a slope of 1. Maybe I'll make that go deeper like that. I bet I have like a little line tool. Okay, so then, and it doesn't really matter which way I shade it. So let's shade it this way. Okay, and so this is a bit of an exercise in like remembering how. So here's my y-intercept. My slope goes down 1 over 1. So that is y is less than 5 minus x. And I think that was one I used in class. So it's less than because here's my y-intercept. So like if I'm at 0, y would have to be 4. Like I'm going this way. Like I'm going like down. Less than. Okay, but we need 2. So let's make another line. Let's get like, what do I want to do? I could do a horizontal line, but that's kind of cheating, I feel like. Let's do, I could do, sorry, I don't have an example ready. So same thing, slope is going to be 1, trying to keep it simple for myself. Okay, and so then for this, I need my shading to be down here, right? Because I need to get that purple dot. Oh. It's beautiful. I'm going to sort of redraw my dots so you can see it. There it is. Okay, so same thing, this is less than, so I'm going below, 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 right? Heading down. And this was 3. So y is less than 3 plus x. So it really doesn't matter the equations that you choose. This is the form y equals mx plus b, which I like, which is called slope-intercept form. Throwback. So the whole number is the intercept, and then the x is the slope. Okay, and then the other thing you can do is like check. So let's do that real quick, just so we have an example. So if I rate this is x and this is y. For number 1, I'm saying is 3 less than 5 minus 2? Oh, I need those to be equal because I drew a solid line, Miss Moose. Silly Billy. I guess I don't need it to be, actually, let's make that. I don't need it on the green. I just need it on the blue because I drew it on the line. So simple for myself here. Okay, anyway. So 3 is less than or equal to 3. Great. So that's because it's on the line, because it's on the boundary line. So for the green one, I'm going to use the same point. 3 is less than 3 plus 2. 3 is less than 5. That's a true statement. Great. Love it. Right? So that one's not on the boundary line. I have this like extra space. Okay. Great. The other thing I want to say is just like a quick thing. So let's go to the next slide. Okay. So boundary line. If it's dashed versus if it's solid. So this is like an open dot or circle, and this is like a closed dot. And this is this is less than or equal to. So this can be equal to. This is a strict inequality. Inequality. Yeah. So, if you have a boundary line that is dashed, you cannot be on the boundary line. If you have one that's closed, you can be on the boundary line. So I'm going to say something like, does not include boundary point or line. Then I'm going to say like does include. I don't know why I'm using the highlighter. Here, let me actually switch to a pen because I'm going to run out of space. Does include the boundary point / line. Okay. So I hope that was helpful. I know that writing the equations is a bit much, and especially for standard form, because we've been using y equals mx plus b for so much longer. Yeah, so just be nice to yourself. Let's do this. Beautiful. Okay, that's all. Bye.